Good morning and welcome everyone to this course, Physics 1. This course is generally made for undergraduate level BTech students. Myself, Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baruipur. You can personally meet me at college premises, ground floor physics lab, or you can also send me the mail regarding your doubts and query to the given mail address, that is godphysics6@gmail.com or gopal.chakraborty_gcem@jazzgroup.org. You can also subscribe my YouTube channel for more videos. So lots of videos I have already uploaded regarding the topics, so you may consult these videos. Now the course pages are www.markoutexam.net or www.markoutwb.ac.in. The syllabus is already uploaded there in the university website. The title of the course is Physics 1 and the subject code BSPH101. So the course is under Basic Science course. It has a credit 4 and 3 lecture per week and 1 tutorial per week. So the course is generally made for BTech degree students of first year. So from different department, computer science, civil, mechanical, these departmental students will going to study this course in the odd semester, and alternatively electronics and electrical departmental students will going to study this course in the even semester. So as it is considered that students those are pass out from class 12, they are going to study this course. So today the topic that I will discuss, they have already a preliminary idea regarding this topic. So they have to know in details that topic, because this topic is related to the subject Physics 1 and it will help you to understand the first module, that is Mechanics 1. Now today the topic that I will cover: conservative force and non-conservative force, conservation laws of energy and also conservation laws of momentum, friction and its different applications. So these topics are actually under module 1 mechanics. So prerequisites for these topics are elementary idea of physics and fundamental ideas of mathematics. Course objectives are: learn about different type of force, effect of frictional force on a body, static or in motion. They can learn about conservation laws of energy and conservation laws of linear momentum. The course outcomes are, that means after completion of this course, students have an idea of laws of motion, momentum, work done, energy. They are also able to calculate the amount of frictional force on a body and applications of laws of conservation of energy and momentum. So the students, those are taking admission in BTech first year, so they have already passed out class 12 having the physics, chemistry and mathematics as a subject. So in physics they have already learned about unit dimension error, rectilinear motion, rotational motion, etc. So where they have already studied that in rectilinear motion the particle moves along a linear path following some equation. V equals to U plus minus AT, V square equals to U square plus minus 2AS, or S equals to UT plus minus half AT square, where V is the final velocity, U is the initial velocity, T is the time, A is the acceleration or retardation. So these things they have already derived this equation in their class 12. So now they have to know what is laws of motion, because for a macroscopic particle all the particle must follow some laws. That laws is basically nothing but Newton's laws of motion. So Newton's actually derive or discuss three different types of laws. First law is related to give you the idea of inertia. Second law will give you the idea of momentum and force, and the third law will give you the idea of force and reaction force. So these are the three Newton's law that all macroscopic particles will follow. So I will discuss these three different laws and corresponding application, because when a particle will follow a straight line of motion, which actually the change of displacement with time in a linear way, so that particle as it is must follow some Newton's laws of motion. So there's some dissipation of energy or some frictional force or different kind of force must be associated with that system. So gradually you may think that your energy will be lost, or maybe the energy will increase or decrease. No, I will show you that for a conservative system, conservative force, that all the energies are constant. So that also follows conservation laws of energy and conservation laws of momentum. So before going to discuss that, you have to know each definition. What do you mean by energy? What do you mean by power? What do you mean by momentum? Okay, so first I will discuss this, then I will show you how the energy of a particle will be constant, okay, with some example. So first of all I am going to discuss the Newton's laws of motion, which is very important for your semester. Now Newton's laws of motion. Newton's laws of motions are three physical laws that together laid the foundation for classical mechanics. They describe the relationship between a body and the force acting upon it, and its motion in response to that force. More precisely, the first law defines the force qualitatively, the second law offers a quantitative measure of force, and the third asserts that a single isolated force doesn't exist. As I have already discussed, it will give you the idea of applied force and reaction force. So these three laws have been expressed in several ways. So first law states that every body persists in its states of being at rest or moving uniformly straight forward, except insofar as it is compelled to change its stable state by force impressed. In an inertial frame of reference, an object either remains at rest or continues to move at a constant velocity unless acted upon by a force. So that means that already I have told you that in a simplest way you can say that without application of any external force, the particle or body continues its state of motion. So that means if it is rest, so it remains rest. If it is in motion, it continues the motion with the same velocity. So this is first law. Second law, the alternation of motion is ever proportional to the motive force impressed and is made in the direction of the right line in which the force is impressed. In an inertial frame of reference, the vector sum of the forces F on the object is equal to the mass of that object multiplied by the acceleration of that object. So from there I can write F equals to ma. For force is a vector quantity and a acceleration is also a vector quantity. So as we know, the acceleration is dv/dt, rate of change of velocity. So if you substitute that value, you will get m dv/dt. So that is equals to dp/dt, where p is the momentum. And the third law states, to every action there is an always opposed and equal reaction. So when one body exerts a force on a second body, the second body simultaneously exerts the same amount of force opposite in the direction of first body. So if we consider 1 and 2 are the body, so if 1, 2 is the force applied on body 1 due to body 2, so that will be equals to minus of F21, where F21 is the force applied on body 2 due to the body 1. So negative sign represents that direction of force is opposite to each other. Now from Newton's second law, we have known the term that is momentum. In Newtonian mechanics, the linear momentum or translational momentum or simply momentum, it is the product of mass and velocity of an object. So it's a vector quantity possessing a magnitude and a direction. So you can write P equals to mv. Now what is work done? So when a force causes a body to move, work is being done on the object by the force. Work is measured of the energy transfer when a force moves an object through a distance s. So when work is done, energy has been transferred from one energy store to another, and so energy transferred that will be equivalent to work done. So work is the product of force and displacement. A force is said to do work if, when acting, there is a displacement of the point of application in the direction of the force. So if F is the force, S is the displacement, so we can write work done will be equals to F dot S. So as it is a dot product, so you can write Fs cos theta, where S is the angle between the force and the displacement. Now what is energy? In physics, energy is the quantitative property that must be transferred to an object in order to perform work on or to heat. The object energy is conserved quantity. Common forms of energy include the kinetic energy of a moving object, the potential energy stored by an object position in a force field. So energy is basically energy is a quantitative property that must be transferred from one object to other. So it can be changed from one form to another form. So from that you can define the laws of conservation of energy, which states that the energy can be converted in form but not created or destroyed. In SI unit, the energy is joule, where is the energy transferred to an object by the work of moving in a distance of 1 meter against a force of 1 Newton. Now it is very clear to all of you that what is Newton's laws of motion, what is force, what is momentum, what is work done, and what is energy. You have also have the conservation of energy law. So with an example, I will show you how the energy will be conserved. Okay. So to explain or to prove the conservation of energy, I have choose this example that a particle is falls freely under the influence of gravity from height small h. So At first, the position of the particle is A, as I have shown you in this diagram. So from A point, the particle is fall down and comes to point C. Okay, the height of A and C is small h. So in between that, I have choose another point, that is point B. So after some time t, the particle falls and reach the point B, then it reaches the point C uninterruptedly. So now what I will show you that the energy, the total energy of at point A will be equals to the total energy of point B will be equals to the total energy of point C. So if the 3 points have the same energy for this particle, so that means the total energy is conserved, as the particle is falls freely under the influence of gravity. That means there is no initial velocity of that particle. So the particle starts with a zero velocity, it acquires the speed and ultimately it reaches the point C. So step by step I will show you how the total energy is conserved. So total energy means the kinetic energy and potential energy. So you have to take the sum of kinetic energy and potential energy to find out the total energy. So for first point A, I will going to show you how you will calculate the kinetic energy and potential energy. The mass of the particle is m and v is the initial velocity. So at point A, the particle has zero speed, so kinetic energy will be half mv square, as we know. So half mv square, that value goes to 0, because at initial the particle has no speed, no velocity, but it has a height h, so it acquires the potential energy due to change in height h. So the potential energy is mgh. So at point A, what we will find, that kinetic energy is 0, but it has a potential energy mgh. So your total energy will be 0 plus mgh, that means mgh. This is the first part that I have completed. At point A, you will find the total energy of the particle is mgh. Okay, so equation 1 shows that total energy at point A is mgh. Now for point B, the particle moves a distance x, possesses a velocity v. Okay, so after some time t, as the particle moves a distance x, so now the potential energy is mg. Now the height changed from h to h minus x, so potential energy will be mg h minus x. To find out the kinetic energy, which is half mv square, so you have to find out the value of v. As we know, as the particle is moving in a downward direction, so you can use the formula v square equals to u square plus 2gh dash, where h dash is the height after moving the particle of amount x. So h dash value you can substitute as a x, so you will get the v square equals to 2gx, as the initial velocity of the particle is 0. So in place of v square, if you substitute that value, you will get kinetic energy at point B is mgx. So total energy will be sum of kinetic energy plus potential energy, that means mgx plus mgh minus mgx. So mgx will cancel out and ultimately you will get mgh. So at point B, again we find that the total energy is mgh. Now came to the point C. So at point C, the total energy will be again the sum of kinetic energy and potential energy. So here, as the particle is almost at the ground, so total height of that particle will be 0. So potential energy will be 0 because the height change is 0. Now, so all the energy will be kinetic energy, so it is half mv square. Again, v square equals to u square plus 2gh. So as h is now the total height change, so it is h. So if you substitute the value of v square, so it will give you half m into 2gh, that means mgh. So equation 1, equation 4 and equation 5, these three equations shows you that each and every point of the motion of that particle A will give you same energy. So with this equation example, it is very clear to you that total energy of the particle is conserved. That means at some point the kinetic energy is transferred to a potential energy, transformed to a potential energy, or potential energy may be changed to a form of kinetic energy, but sum of these two will be always conserved. Now came to the second point, that is laws of conservation of linear momentum. It is almost same as your laws of conservation of energy, because it says that without application of any external force the particle retains its total linear momentum. That means your total linear momentum will be always conserved. Okay, so here I have shown you that an example, that is recoil velocity of gun. So with the help of these conservation laws of linear momentum, you can calculate the recoil velocity of gun. As I have chosen an example, so a gun is there. Okay, so before firing, the bullet is inside the gun. Okay, so after firing, the bullet is moving in the forward direction, and you know, when the bullet is moving in the forward direction, the gun is trying to move in the backward direction. So you are going to find out, or I will show you how you will calculate the velocity, recoil velocity of that gun. So this is an example of conservation of linear momentum. So what I considered, before firing the mass of the gun is capital M and the mass of the bullet is small m, and after firing the mass will be remain constant, but initially before firing, as the two bodies are at rest, that means both the gun and bullet are at rest, so the velocity for those are 0. But after firing, the bullet acquires a velocity small v2 and the gun acquires a velocity capital V2. So initial velocity small v1 for the bullet is 0 and capital V1 for the gun is 0. So as per the conservation laws of linear momentum, total initial momentum will be equals to the final momentum. So you substitute that value, small m v1 plus capital M v1, that is equals to small m v2 plus capital M v2. So initially in the left hand side, v1 and small v1 and capital V1 both are 0, so left hand side is equals to 0. From right hand side, rearranging, you can write capital M v2, that is equals to minus m small v2. So capital V2 is equals to minus of small m by capital M into small v2. So capital V2 represents the velocity of the gun, that means recoil velocity of the gun, and the negative sign signifies that it has a direction opposite to the direction of small v2. That means it will move in the direction opposite to the direction of the bullet after firing. Now the conservative force and non-conservative force. So what is meant by conservative force? So conservative force is a force with the property that the total work done in moving a particle between two points is independent of the taken path. Equivalently, if the particle travels in a closed loop, the total work done, that means the sum of the forces acting along the path multiplied by the displacement by a conservative force is 0. Okay, so that means for a conservative force, the path of the particle is independent of with the total work done. A conservative force depends only on the position of the object. If a force is conservative, it is possible to assign a numerical value for the potential at any point, and conversely, when an object moves from one location to another, the force changes to the potential energy of the object by an amount that does not depend on the path taken, contributing to the mechanical energy and the overall conservation of energy. A force field F defined everywhere in space is called a conservative force or conservative vector field if it meets any of these three equivalent conditions. What is that condition? First one is del cross F equals to 0. That means curl of the force is 0. The work done along a closed path, that is F dot dr, that will be equals to 0. And the force that is equals to minus of grad phi, so negative of potential gradient. So if any of these three conditions is satisfied, that means the force is a conservative force. So lots of examples are there for conservative force. The force of gravity, that means when a particle falls freely under the influence of gravity, this is an example of conservative force. Or when you attach a spring with a mass and the mass is now moving due to stretch of string, so this is also an example of conservative force. Now the non-conservative force. So non-conservative force is the force where the kinetic energy of that particle which are in motion depends on other quantity. So other quantity means say velocity or the path of the motion. So as you know, the conservative force doesn't depend on the path of the motion. So here for a non-conservative force, actually the kinetic energy depends on the velocity and or the path of the motion. So the frictional force, the non-elastic stress, these forces are example of non-conservative force. So you can say that despite conservation of total energy, non-conservative force can arise in classical physics due to neglected degrees of freedom or from time-dependent potential. For instances, friction may be treated without violating conservation of energy by considering the motion of individual molecules. However, that means every molecule's motion must be considered rather than handling it through statistical method. So, what is friction? Friction is the force resisting the relative motion of solid surface, fluid layers and material elements sliding against each other. So there are several types of frictional force. So mains are static friction and kinetic friction, which are included in your syllabus. So static friction means it is a friction between two or more solid objects that are not moving relative to each other. For example, static friction can prevent an object from sliding down to a slope surface. The coefficient of sliding friction, typically denoted by mu suffix s, is usually higher than the coefficient of kinetic friction. So static friction is considered to arise as the result of surface roughness features across multiple length scale at solid surface. Now the kinetic friction. Kinetic friction, also known as dynamic friction or sliding friction, occurs when two objects are moving relative to each other and rough together. The coefficient of kinetic friction, typically denoted as mu suffix k, and is usually less than the coefficient of static friction for the same material. So here the examples are, suppose if someone tried to pushing open a door, they applied a force in the direction of the door, but the door is not opening, and they also apply in the opposite force to that man, but there is a arising of the frictional force between the hand surface and the door surface. This is also an example when a particle is sliding through a slope. So the lower surface of the particle and the upper surface of the slope, there is a molecular attraction between the atoms or molecules. They arise the frictional force. Hope all of you have understood the very basics of friction. But what do you mean by friction? Both static friction and kinetic friction. Now I will show you some example over that friction. So first problem is that a mass 4 kg rests on a horizontal plane. The plane is gradually inclined until at an angle theta is 15 degree. With the horizontal, the mass just begin to slide. What is the coefficient of static friction between the block and the surface? So you can see the diagram is here, which actually shows the weight of the particle is directed in a downward, making an angle theta. So it has a two component, one is mg cos theta, another one is mg sin theta. So mg cos theta is equal and opposite to the reaction force N, so with that will balance. So now mg sin theta, that achieve a force in a downward direction, so the frictional force will act in the opposite direction. Okay. So as I have told you, you can write the equation of motions are mg sin theta is equals to Fa, so where F is a static frictional force that will balance, and mg cos theta is balanced with the reaction force M. So from these two you can write the tan theta, that will be equals to F by N. So that is the frictional force by reaction force, which will be equals to the coefficient of static friction mu s. So substituting all these value, you can easily get that theta, that angle is 15 degree, that is given. So mu s equals to tan 15, so that is equals to 0.27. Now this is the second problem on friction. The problem is what is the acceleration of the body and trolley system shown in the figure if the coefficient of kinetic friction between the trolley and the surface is 0.04, and what is the tension in the string? The G can be taken as 10 meter per second square. Now neglect the mass of the string. You can see the diagram is given here. So from that diagram, how I will solve this problem? The procedure is you have to find out the equation of motion. So equating all the force, you can easily find out what is your tension or what will be the acceleration. As the weight of the trolley that is given here, mass of the trolley that is given here 20 kg. So that will be equivalent to the reaction force acts for the tension. So N can be written as 20 into 10 Newton, so 200 Newton. So the tension T minus 0.04 into 200, that will be equals to 20A. So from there you can easily calculate the acceleration is equals to 96 meter per second square, and the tension is equals to 27.1 Newton. So these are the books that you can refer or consider as a reference book. Laws of examples and concepts are given there regarding these laws of motion and friction. So hope all of you have understand today's class. In next class I am going to discuss regarding the equipotential surface, rotational motion and moment of inertia and its application. Thank you.